who are the AVLs for these types of orders where maybe it's high mix, but it's sustained production, or maybe it's just high volume.
Yeah.
And, that is it always just DigiKey or Mouser? Are you going directly to like the semiconductor vendors or the capacitor vendors or who else?
So I think the supply chain right now is changing a lot. Basically when you don't have a lot of that visibility, you're always going to go to the DigiKey, the stocking distributors. Let's just call them that, which is DigiKey, Mouser, Newark, people like that, where they just sit on it, and the cost is going to be a little bit more expensive than if you go to the supply chain distributors.
Hello, everyone, and welcome to the Altium OnTrack Podcast. I'm your host, Zach Peterson. Today, we're talking with Jay Patel, CEO of Amtech. I always like getting manufacturers on here to talk about PCB design and PCB issues because, of course, as I've told many people, I've made it my mission this year to learn as much as I can about manufacturing. So I'm very happy to have Jay here today. Jay, thank you so much for being with us.
Well, thank you. I appreciate the opportunity.
Yeah, absolutely. So you are CEO of Amtech, which is an EMS, and you are new on the podcast. So, if you could, just give us an overview of your background and how you got started in the electronics industry.
Yeah, so my father started the business. He was originally he did a few PCB fab houses. He's a partner in them. Didn't work out for a couple of reasons here or there, and then he took a break from it. My mom ended up working at Jabil right here in Michigan. She was at the first Madison Heights facility and then moved, and she kind of was there when the whole thing, when Jabil really scaled. She was solder tech and repair tech, and my dad always had this bug in him to start an electronics company. My mom knew how to solder. I was young and cheap and available for work, so my dad launched the company. I've worked, I think in '95 he started the company, and I was in high school, college. I worked throughout there, and then as soon as I was ready to come in full time, and I started, my education process stopped. I've been with Amtech from the beginning, so I've actually worked at almost every single position in the shop floor, from soldering to testing to machine programming to machine operation to optimization to inventory, MRP. I have learned everything the hard way all the time. So I know the process very intimately.
Yeah, that's interesting for two reasons. First, it kind of mirrors my, experience just as a child, because my father was a cabinet maker, and so I kind of grew up around that environment and had to work every position in the shop. So I get that feeling. But it's also interesting because I think a lot of companies in the US are, as they would say, mom and pop operations, and, eventually kind of get passed down to the next generation.
Yeah, I think, right now you kind of see it with farms because where it goes from generation to generation. And that's simply because of the capital investment is so high to actually break into it. It's hard for people to kind of put the money together to launch a manufacturing company. Once it's in the business, and I think manufacturing companies are becoming that. They're kind of like becoming the next version of a farm, where it stays in the family. Kids come in, they work there, and it's a natural transition for the kids, if they choose to, for the kids to take over, because they've been around it their whole lives.
So if you could, for some of our listeners who maybe have not ever dealt with a company like yours, which is an EMS, could you tell us what is the difference between maybe a prototyping shop or a quick turn prototyper or a quick turn assembler and a company like yours? Is it just a matter of volume, or is there something different?
I think there's a few differences. Inherently, it's the same thing. We're taking circuit boards and soldering components onto it. However, when you want to get a little bit more sophisticated and want more repeatability, there's a lot more robust processes that you need to put in place. There is a little bit, and as you scale, you can't micromanage everything. You have to really get a good team going and create the processes around that. When you're a prototype shop, it's a one and done. You get it in, you can have a guy, you can push it through, you can and it's pretty easy. I mean, I'm not saying easy. Let me take that back. It's different than when you want repeatable results for a particular product. The margin is less. The margin for error is less. The repeatability and expectations, and people rely on your deliveries even more. So you need to create a really, really good team. And when you need to have a good team, you need to identify where the wastes and the risks are throughout the whole process, and start doing some Kaizen or continuous improvement and poke-yoking the process, or implementing some sort of hardware or software automation, so that you can focus on what the customer wants, what adds value, rather than just spinning your wheels or doing some other tactical stuff that's not going to be able to add value to the customer.
So there's another, I think, wrinkle there when we talk about maybe the difference between, a quick turn prototype shop and EMS. I get the one and done part of it versus repeatability, which makes a lot of sense. And I think that kind of serves the volume production customer. But is there a difference in general between the capability you can expect at an EMS versus a quick turn prototype shop?
I think I think the shops are set up differently, the processes are set up differently, and the supply chain, most importantly, set up differently. When you're a quick turn prototype shop, you're working on whatever the catalog distributors have in stock or you've pre-bought. When you're doing stuff in production, your supply chain really becomes a really, really important partner to you. So I think the gear that you run out in the shop, the software that you have to help you set that gear up, is different in both prototype and production scenarios, as well as supply chain.
So another question I think more specifically about your company is, what makes your company different from other EMS companies?
Yeah, so I think I always say this, and I don't kid myself when I say, if I was to shut my doors, none of my customers would miss me in the state of Michigan, in my county, in the state of Michigan, or globally. So what is the differentiator for Amtech to really exist? I think one thing is, the biggest differentiator always comes down to your team. So I think our team is a phenomenal team. We've really, really created a great team that is customer focused. And because of that, we've been able to leverage our relationships internally and execute on them to become almost like a quick turn production house. So we've had customers come to us and say, hey, we're behind on this project. We want to launch. Supply chain and everything is saying, 12 to 16 weeks. Can you do any better? Or even more than that. And we've been able to shorten the launch times for production to 6 to 8 weeks. Another thing that we do is we try to be able, we set up our hardware tech stack and our software tech stack and increase the process window. So anything you throw at us, we can quickly launch without a lot of quality issues. So, some of the differentiators we have is the type of gear that we run, our SMT equipment, our software that supports it, our NPI processes. And one big thing that we have is a vapor phase reflow, which allows us to provide the best type of reflow, no matter the complexity of the board or the simplicity of the board. And we will always have a good solder joint. So we don't have to go through the iterative process of creating a good reflow profile for that. We just throw it in there, and it just does a phenomenal job for us. So I think we've set ourselves up differently in the sense that we want to be a high mix mid volume shop, and our sweet spot is quick turn production, not necessarily quick turn prototype. We will do quick turn prototype if we have a shot at the production, but we're not just a quick turn proto house.
Sure. Now, you've mentioned something a couple of times here, and I haven't asked you about it specifically, but you've mentioned supply chain, right?
Yeah.
And obviously, if you're going into volume production, the ordering process and managing all the logistics and everything is going to be a little bit different than if you're just, throwing a board at JLC PCB and, selecting the LCSC part numbers or whatever. So clearly there's a different approach. Can you dig in a little bit more on the supply chain aspect that you deal with as an EMS versus what a customer might see if they're dealing with like a prototype house or if they're just consigning components from like the franchise distributors?
Yeah, so I think when we go into production, we have, before we launch, and this is something that we do with all of our customers, we have to do a complete supply chain risk analysis to see if the parts that are in the BOM will allow us to stay in production for the life cycle of the parts. And the sooner the customers get us involved in that side, where they're, before the BOM is locked in, the sooner that we can identify those, the sooner we can provide them feedback, and they can change or update update their either design or their AVL to ensure that we don't run into parts issues. Now, once that is done, then we have to go around to and find partners, the supply chain, that say, okay, this is our, and we have to get a commitment from the customer. We have to get some type of forecast or promise or POs or supply chain agreements with them going, so then we can go back to our vendors and say, hey, look, we're launching this program. We're going to need some safety stock. We're going to need visibility. We're going to have a really, really tight relationship with this. Let's make it happen. And then you have to talk to them and work with them to build that supply chain going. So there's a lot of bonded inventory programs. There's a lot of programs where they actually have inventory in-house that once you take it, it becomes yours. So they store, they warehouse our products that they own in our warehouse. So then it's quicker for us. So there's a lot of different programs we have to really work with. And I think that's when launching those production processes, I think that entire step is a different mindset that we have to make. And we have to make sure that we work with our vendors. I always say that, especially electronics manufacturing, customers will come and go, but you're going to be stuck with the same distributors, or you're only going to have access to the same distributors. So the better relationships you have with those distributors, the stronger you'll be in the long term.
I see. And you mentioned the AVL, right? I think most people would just kind of throw, DigiKey, Mauser, or Newark or something like that on their AVL. But who are the AVLs for these types of orders where maybe it's high mix, but it's sustained production, or maybe it's just high volume? And, is it always just DigiKey or Mauser? Are you going directly to like the semiconductor vendors or the capacitor vendors or who else?
So I think the supply chain right now is changing a lot. Basically when you don't have a lot of that visibility, you're always going to go to the DigiKey, the stocking distributors. Let's just call them that, which is DigiKey, Mauser, Newark, people like that, where they just sit on it, and the cost is going to be a little bit more expensive than if you go to the supply chain distributors, where they really focus on forecasting and creating a safety stock, a bonded inventory program, where we're giving them continuous updates so they can hold that inventory for us. So there's that tier. So we have our stocking distributors, we have our supply chain distributors, and now what's happening that's really, really different is a lot of these OEMs, component manufacturers, are trying to go direct. So TI is working on that. Analog Devices is working on that. There's a lot of other companies that are trying to go direct. And so the entire supply chain arena, or the way that we integrate and work with our vendors, is changing right now because some OEMs or component manufacturers are deciding to sell directly. So now when we're looking at different programs, we then also have to take into consideration that, because ultimately we need to make sure that our price is competitive, especially if we're trying to focus on reshoring and onshoring product, which is a big push right now for us. And we've seen a lot of interest in that. We need to make sure that we have the most competitive pricing, because at the end of the day, our BOM, from 40 to 70% of the BOM our 40 to 70% of our cost is the BOM. So anything that we can save on that makes us that much more competitive.
What's driving that from the manufacturers, right? You mentioned Texas Instruments, Analog Devices, right? Doing a kind of an e-commerce model where you can just go onto their website and order parts. Are they just trying to cut out the stocking distributors as middlemen?
So let me take a step back. I know TI does it. I know Microchip does it. I may have misspoke on Analog Devices. I don't know. I'm not confirmed on that, so I don't want to spread anything. But it always comes down to what's the business case. I think what they want to do is they want to instead of give that margin to distributors, they want to have the same price or take, one point off and save the margin. So they're making that money internally. So I think it all comes down to economics. And, the big thing is I've always seen it all comes in circles, in waves or, a pendulum. Leadership comes in, they want to go direct. And then another leadership comes in and says, hey, could this go on direct? Is adding too much overhead? This may not be what we do. Let's go and engage with distributors again. So I don't know if this is forever. I don't know what it is, but I know right now there are multiple component manufacturers trying to go direct, and I don't know how long that's going to last.
I could also see another business case for that to be like introduction of, new parts to key customers, that kind of thing, where they can, really build that relationship and try and get companies to like lock in to
Correct.
more and more components.
Yeah, and they've had to really do that. TI, I know TI has built up a good FAE team that we work with directly on. That our customers, we don't do design yet, but our customers would work with them to. And I agree with you. It's ultimately this is a relationship business that is long term. So the better relationships you build with your EMS companies, your distributors, or even the component manufacturers, then that's going to drive what gets designed into the BOM, and that's going to drive business. So I think, if and that's a good point. If they want to own that relationship, it makes sense then.
Sure. So speaking of designers, I think this is a good point to transition and ask you, what are some misconceptions that design teams have when they start to make that transition from prototyping to dealing with a company like yours that might be offering kind of this, quick production model, or that might be producing an order at higher volume? Like I just want to bring this up, right?
Yeah.
Producing at like 20 units is way different than producing at 20,000 units. So I want to hear from you. What are the big misconceptions from designers?
Yeah. So I mean, I don't know how long you've been in the industry. You can see my gray hair. I've aged like presidents. After the supply chain issue, I've aged like a president. Every year is like 3 to 4 years for me. But I think the old guys, and when the transition was being made from surface mount from through hole to surface mount, a lot of the engineers said we don't like surface mount because we can't iterate. I can't swap a resistor out, or I can't swap an IC out. I would like to be able to have that capability of doing that, because if I want to do surface mount prototype, I have to get a stencil, and I have to pay for machine setup and machine programming and all this kind of stuff, and it adds. I just want to use through hole, and I think that is indicative of the same way. I mean, obviously we don't use through hole anymore because I just don't think you can get those type of parts in through hole. But now the same way is, I think people, when they're prototyping, they build it so it's ease of prototype. But then we always have, and that's okay for initial design validation builds, engineering validation builds. That's fine. But as soon as you go into production, there's a lot of things that need to be taken into account for. Is we need to design quality in, remove design risks out, design automation in, so that we can provide consistent quality and delivery to our customers with a really, really simple manufacturing process that's designed for that particular product. So I think when we take a step back, and we're in Detroit. We've been lucky enough to start working with Apple since they started their Advanced Manufacturing Academy over here. And one of the things that we really talked about is, all right, so how can Apple help us? And I think what we started out with is, let's focus on creating a process and organization that is easy for customers to reshore, onshore, and make it confident. And I think what we started out with was their DFM, design for manufacturability, and design for assembly rules. And Apple's actually been helping us design those rules that they use in their products, and they've kind of shared that with us right now. So I think, even talking to them, the first part of production success is DFM and DFA. And those things we're talking about, like, what can we do? Can we make it single-sided or double-sided? Can we remove the complex components? Like, do we really need a micro BGA on this? Like, do we really need it, or do we have enough room to be able to put different type of components that can be inspected by an AOI or that can be swapped out if the component fails easily. So we try to really talk to our customers. Like we have a particular customer launching the BGA HDI on the boards, takes a long time for it to fabricate. And there was a drop-in replacement of that particular part that was a QFN. So the next generation that's coming out is going to have QFNs. That's going to lead to a lot of issues. Now we're lucky enough that we have a vapor phase reflow and we've been pumping out, the BGAs, no problem. But this allows us that flexibility that if anything does happen and we do need to rework it, it makes life a lot easier to rework a QFN than it does a BGA.
There's a couple of threads I'm hearing here, right? You brought up DFM, but with DFM, there's an associated, I guess, DFC, right? Design for cost, right? Because
correct.
You could design it perfectly, but it might be a Ferrari, right? So you followed all the right design rules. You took account of all the possible assembly defects and did what you could in the design to address it. But at the end of the day, it's a way overbuilt design. It's a Ferrari. And then there's the Kia, right? You would love to make it really cheap and inexpensive, but it still does all the stuff that the Ferrari does, right? And so the DFM approach is probably a little bit different there. And it sounds like you guys are able to maybe identify some of those issues that could help reduce the cost involved, either when you're building the Ferrari or when you're building the Kia. Or maybe make your Ferrari look more like a Kia.
Yeah, I think... Yeah, we have that. And the thing is, we do the best when our customers allow us to engage with that process. If they just give us a final print and we have to build it, well, then we'll build it. But we can add a lot more value to that. And really, we add value at no cost. Like once you launch it, once you're a customer, we like to be very, very tight with the engineering team that works on next generation of products when it comes from BOM and when it comes for layout for the circuit boards. One thing that we really push for, and we've converted a lot of our customers is, through-hole components are still an issue, but at every single point when we can, we change it so then we have pin through paste, we create solder preforms. So now, those through-hole components that leads to a lot of defects, a lot of processing, that's there, a lot of manual work, we can just get it done in the SMT reflow process by adding those things. So we have that opportunity and we take those type of opportunities with our customers.
And then another thread, I guess, from the DFM, DFA is quality control, right? And I think this is another big misconception that designers might have, because if they try to produce the Ferrari at a quick turn prototype house, the yield might be horrible. Right. The yield might be 50%, but you as the designer don't know that. You were just happy that you got your 10 boards back, and you don't care if they had to build 15 or 20 of them in order to get you your 10 boards. You got your 10 boards and they work. Right. Yeah. Whereas if you're going into an EMS, quality sounds like a lot more of an issue because you have that margin compression, and because you are probably trying to prevent a lot of that manual rework that would arise, which then, of course, eats into your margin and possibly adds cost to the customer.
Yeah, I mean, I think that is a very valid thing, and that's very important. And I think when you're developing a product, like, you need to know that it's not a manufacturing defect, because if it's not working, you're always going to default to, hey, it's a engineering defect, and ultimately you lose a lot of time, you lose a lot of resources, you lose. It becomes a frustrating process for everybody. So even when the engineers design it, they need to focus on design for manufacturability. And in the case that they can't, that's why we've kind of developed our hardware tech stack with the vapor phase reflow, our SPI, our pick and place machines, where you may have defects at Amtech, but soldering is not going to be a defect. So everything is always going to solder well. So that's why we've kind of, you asked how do we differentiate ourselves. That's one big thing, is we've widened our process so much that we can take anything you throw at it. And we've done boards that are 18 to 20 layers or more, high mass and small boards. And it's really, really, it's been really a great process for us. But that luckily we can do that. But other EMSs, yes, they need to get the engineers to understand that it has to be built and manufacturable. Even like small little things is if you keep a via too close to a pad, it's going to take solder paste. And when it takes a solder paste, what happens? You can have bridging, you can have tombstoning, you can have, I have an instance where a customer put a via under a component, which is shorting it to ground. And that's just, it creates all these issues. So it's very important that the engineers go through a DFM process and make sure that the board is set up. So the design is robust so that when you build it, it will work all the time.
Sure. And then going back into quality control, I think this also relates back to capability, differences between, an EMS and a fast prototyping house. Maybe if you could tell us, is the testing and QC processes and capabilities different between those two types of companies?
Yeah, I think there is, and it's changing a lot, to be honest with you. We've been implementing AI-based and machine learning-based visual inspection now, which gives us, it takes about 2 minutes to program, and boom, we're ready to go. We're inspecting products. So even if it's a low mix or low volume product, we can get that. So I think testing in quick turn is more visual, and quality control in quick turn is more visual, and quality control in production is more electrical. And so you're actually doing a functional test or ICT test or measuring components or measuring values on the board. And that takes a little bit additional firepower and sophistication to be able to build that. It really sucks because when you're built, or not sucks, but it's really a challenge because not only are you developing a product and you finally develop that product, now you have to create another product, which is a test that tests that product. So you have double, you have to increase your engineering effort to be able to build that product. And a lot of companies don't like to do that. A lot of companies outsource that. We've been working with a great company that helps us do quick turnkey end of line testing. And it's been working out for our customers, but it is an effort that needs to be made because at the end of the day, the test, there may be a capital expenditure for it and labor associated with it, but it's still cheaper than accidentally sending an entire batch that doesn't work over to the customer. And how are you going to manage that? Line down situations, what are you going to do? It's just, we have to test, and we will test all product going out the door in a production type of environment.
So when you're dealing with clients, right, they send you data, and a lot of the DFM, DFA gremlins are probably hidden somewhere in that data, and maybe the designer or the customer doesn't even know about it, right? What are some of the common challenges that you see when dealing with data as part of a customer order?
Yeah, so I always say that, electronics is almost $1 trillion industry, and we have no standards on how we communicate our data or how we develop our BOMs or how we send over PCB fabrication notes or stack ups or anything. So every time we get a new data package from a customer, we have to go through it. And it is painful because the BOM has a different format. The mechanical information is a different format. The drawings have a different format. Where's the conformal coding information? If it's there, we have to look at every subnote and everything to make sure that it's built properly. And if there is any discrepancy in our understanding versus what the customer wants, it just creates a bad experience for everybody because, you have one shot to give, especially for new customers, you got one shot to lead with a good impression. And once you get the program and they put faith in you, if there is a discrepancy between the understood scope of work and the expected scope of work, it leads to friction. And that's not good for us because we want to provide a service to our customers. We want to add value. We want it to be seamless. So right now, it is really painful. Here's a use case. Customer comes to us with a production order, a new production order. We're quoting it. We quoted it. We won. Right? We're launching, doing NPI on it now. Now, when the NPI happens, the board house really digs into the design and says, okay, there's these issues on here. Now, if the customer it's a time sensitive launch, and the customer wants it, and we promise them that we'll get it to them. Now, when we go and launch it, the board house comes back with EQs. And then we have to go to the customer. And the customer says, well, I don't understand this. Why are they asking this? And then we go back to the board house. And that that slows us down by 2 to 3 days. And if
At
that
least, right?
at least, yeah,
Yeah.
at least if that's the customer is engaged with us and gets us our answers the right away. And if we're working with domestic board houses, if we're working with overseas board houses, it takes 24 to 48 hours to get a response for them, and then we wait for the customer. So we're talking about a week or two just going back and forth on PCB fab drawings and making sure we get it the right way. And if the board is not good, nothing you build on top of it is going to be good. So this is a very critical step in the entire process to launch electronics, and it is not standardized, and it leads to a lot of issues, and it just leads to a lot of lost time and a lot of non-value added work. I was in this industry, and I wish there was a standard, and I think that's where we're going to kind of talk about is what are the standards we can talk about now is what are the standards that we can use to do that handoff to EMSs and PCB fab houses to ensure that it's been launched properly and there's no risk. We've reduced any type of risk, all type of risk for that launch to the customer.
Yeah, I would like to talk about that and specifically the smart data formats. But one thing that's interesting about this is I've always wondered why the electronics industry has not developed some kind of standard. I mean, given the clear size and importance of the industry, and I would like to underscore the importance there because I mean, literally everything in our modern life is enabled by electronics. So it's a little confounding to me why there isn't some sort of better standard and why the smart data formats haven't been adopted as a standard. But another question that this kind of brings up is, do other industries have some sort of standardized way that they communicate data between customers and process engineering?
So I am not an engineer. I'm not too sure. I know when it comes for mechanical drawings, there are ways for machine houses and injection molding and stamping and all these type of all these other type of mechanical processes. I know there's a standard way that those guys get their data, and those guys bring it into their what is it? Their software. I forget the type of software. It'll come back to me. It'll come to me. But they have ways they can import it seamlessly and be able to launch it. And I don't know why for electronics we don't have it.
Interesting.
It's really if you look at it, electronics has grown significantly in both volume and complexity. And when something is growing that quickly, sometimes like I'm in Detroit and automotive engineers always say we have enough time to do a bad job, just enough time to do a bad job. So I think there is one of those things is it is so diverse. Products are so diverse, requirements are so diverse that people are just busy doing and not stepping back and saying, can we do this better? Because everybody's under the gun all the time. Small guys, large OEMs, are trying to launch product so they can stay competitive. Small guys don't have enough resources to stay competitive. So they do it the best way they've learned, and that works with their EMS board house type of relationship. So I think I really don't know, but I do know everybody's in electronics industry is busy and they're growing and they're launching products that are more and more sophisticated at a higher pace. So maybe we've just been too busy to step back and say, hey guys, can we do it better?
Interesting. This is also a little confounding because I talk to investors and investment groups. Sometimes they want consultation on investment opportunities, and there's been a lot of recent interest in electronics due to reshoring, due to defense tech and those kinds of areas. And they're always, a lot of them come from the software world. They're always a little shocked when I tell them that there is no like design file, vendor neutral format, right? It's only vendor neutral once you get to production. And even then, it's really not vendor neutral in a way because there isn't a standard around how you communicate all of the other stuff beyond just what's in the Gerber files.
It's one of those things that I don't know why it's not better. I don't know why there's not a standard. And if there was, life would be much better.
Yeah, I have to wonder if it's due to like all the complexity of the different processes that might need to be implemented in different boards, right? I mean, different boards need different plating. Some of them might need, via plug and fill and things like that. And when you just kind of go down the list, it seems like, wow, this standard could get so complex that, your average designer might have a lot of trouble working with it. Then is it a good standard?
But I mean, like, well, that's a standard, right? Like a standard will cover 80 to 90% of the stuff that you want it to. And there's always going to be exceptions to it. And there's always going to be footnotes. And we should, the standard should say, how do you manage non-standard things? And that should be part of the standard. So I think, I just don't know. I wish there was a better answer, because for us, when we get bombs, every time we get a bomb from a customer, it's just like, oh my God, like, how do we understand this bomb? Or how do we understand this Gerber, and how do we understand this layout? Like, how do we even do it? How do we even design for test? Like, how do we even do it? It's tough because like when we get the boards, we ask the customer, can we change the test points? Can we do this? Can we do that? And the customer, for them, sometimes it's inconsequential. So we do. And so we get good yield. But when the customer wants to move that or wants to iterate on that or makes the next generation, their CAD data doesn't match our requirements. So they're going through that whole learning process all over again. Well, we already optimized the job for, so then they don't do it, they iterate, they come back to us. We have to go through the whole process again, and then we have to try to launch again. So it is a process that is a non-value add process that can be streamlined if we chose to.
Maybe that's the source of the problem, is that there is no standardization in the design library, because at the end of the day, some of those issues that you mentioned, they actually originate in the design library. And if 10 different designers have 30 different library formats between them, good luck getting any kind of standardized communication on some of those things that you see in a Gerber or in a BOM, especially the BOM, right? I mean, the parameterization on parts from one designer to another can be all over the place. I mean,
Correct.
Between naming, the data they decide to include, on down the list. So I guess it's not surprising that you get DOMs or you get BOMs from a customer, and it's like, what the heck am I even looking at?
If you push it or give them an option, like, when we started out, we had to start asking for particular formats for our CAM software. So then it can create the visual aids, it can create the different things that we need for our machines, selective solder machines, pick and place machines, screen printer, SPI, all these different things. And we had to teach our customers that we need these formats from them, And once they did, they kind of started obliging, and they learned that, okay, when we can't just send Amtech a bill of material in Gerber, we have to send them these files so they can do the CAM process. And I think if there's a critical mass of people who identify a standard and start asking for that from customers, I think it'll start happening. It's just we need to get to a point where people know that they're standards. And the second thing is we need to get to a point where we're asking for them, whether we use it or not. We need to start asking for that, so then we can get the customers to give it, OEMs to give it to us. We can start using it. We can request our PCB board houses to be able to give us that information and start using it. And then I think it's just about training and working on getting that to become like the normal. And we just have to choose. Like, there are a lot of standards out there. Like, there are library standards out there, but I don't know how many people and how many enterprises actually use those library standards. There's a lot of spacing standards out there, and I don't know if anybody uses those standards. There's a lot of BOM standards and PCB layout standards. I don't know if anybody uses those standards. So I think it's a lot about it's about awareness, and then it's about just getting the habit of asking that. And like I said, when I go, going back to it, is I think people are so busy just doing and fighting the good fight that there's no really room for engagement. And in EMS, we want the customers to give us the data package any way they can give it to us, so then we can win the business. If we become a point of friction, like, hey, we'll only quote the job if you give them this, and these files, and they're not used to it and they don't want to learn, they're just going to go and give business somewhere else. That's easier for them. So I think that's where, that could be one of the reasons, is just, as a vendor, you bend over backwards to the customer.
Yeah, that's understandable, right? You're willing to kind of compromise just to try and get somebody to send you a PO. I think as you kind of go down the list and look at all the different pieces of information that have to be sent along with your Gerber outputs, you start to get some motivation for why we would have some of the smarter data formats. So I want to know, what are some of your thoughts on smarter data formats like ODB++ or IPC 2581?
So IPC 2581 was introduced to me when we started working with Apple. With our whole DFM and DFA process, they said, I said to them, I'm trying to get some data formats out there. I'm looking at ODB++, but ODB++ doesn't have everything in there. It's kind of incomplete. The board layout and stack up information is not in there. The ideal is IPC 2581. And if you look at all of the ECAD software, they do have IPC 2581 export on there. Now, the big question is, are the OEMs, doesn't matter what size they are the OEMs used to exporting that or not? And are they used to creating their libraries to be able to get that seamless export out of there or not? And then the second thing is, are our board houses able to extract the information from there and then give us a good quote and a good board from there? And we have to train them on that. And I think, if I had to rank which ones to use, IPC 2581 is probably the best one. ODB++ has become more ubiquitous because of testing and because Siemens kind of just open sourced it. You can download the standard for ODB++. You can build software around it. You can do everything. IPC 2581, it's part of a community. You have to buy it. You have to have access to it. And I think that's where a little bit of the friction point is. If you want to create a standard that everybody uses, but you sometimes make it hard for everybody to understand it, it just adds more friction to the entire process. But if we were to use it, IPC 2581 is probably the best standard to use, from what I understand. I had an opportunity to talk to Dana Korf, and I think you've done that in the past as well. He's one of the authors of IPC 2581, and he identified this issue a long time ago, and he designed IPC 2581 to talk about and address a lot of these non-standard, varying different type of data packages that we get. And I would love to use IPC 2581. It's just, at this point, we again have to be aware of it, because I don't even know if people know that there's other options out there than, BOM, Gerber data, and a separate stack up document that can really alleviate a lot of these issues.
Yeah, I'm wondering if one part of that problem, especially among maybe the next generation, or even among some of the high volume customers, is I've been told by Dana Korf directly that when they go overseas to China and they go to some of these companies, they just call everything Gerbers, right? They don't care if it's ODB or IPC 2581. They just call it all Gerbers. And some of them won't even accept ODB++ or IPC 2581. They don't even want to look at it. Do you think those are some of the big roadblocks to greater usage of these smarter data formats?
As soon as the customers start demanding, and you start demanding, I think it'll start happening a little bit more. It's who's going to take the first step? Who's going to do it? I think as it becomes more and more understood and well known, I think people will start going towards that route. I think even Gerber went through different iterations that we have right now. Even the Gerber packages right now are in different formats than they were originally. And I think what we just need to do is make sure that we whoever's out there can make people aware of these type of standards. And once we do that, I think just as an EMS, if the customer gives us, just gives us Gerber data, board stack up, and bomb, and we have to run with it. If we only provide that to the board houses, eventually the entire supply chain was going to have to conform to this. And I think it's just a matter of getting in the habit of asking for it, becoming aware that these standards exist, and then sending that to the vendors. And sometimes, when we started asking for our format for the CAM, I used to have to get on the call with the customer and walk them through how do you export the files that we need from your CAM system. And I think the same way, if we need to do that with board houses, we have to say, okay, this is your CAM system. This is how you import the file into your CAM system. And it's just about helping them get through that initial learning phase, so then they get a little more comfortable. Maybe we give them, the IPC 2581, tell them to come back with us, and then give them the Gerber data so they can confirm that there is nothing different from them, because it's always the fear of the unknown sometimes. So if we give them two packages and say, hey, let us know what you get from both of them, and then we can alleviate that risk or that fear of implementation, because they have a fallback on that could be a process that we start implementing to get that's what we may do as Amtech to get our board houses to accept those type of formats.
Well, I get what you're saying about, educating your vendor or trying to educate your customer. I mean, I think I have a little two problems with that to an extent, right? One is like, how do you scale that, right? I think a lot of companies may not be willing to go out on a limb and do that unless they see the dollar signs at the end of it. I think another issue is, in order to get some companies like, I'm going to use JLC as the whipping boy here, and not trying to say anything negative about JLC, but I think the only way to get a company like that to change their ways and start accepting something like IPC 2581 is for every one of their customers to show up and email them en masse to say, why won't you accept IPC 2581? And I just don't see that as being a feasible or a practical outcome. But what are your thoughts on that?
You have to be the eternal optimist. So I think if before you start something, if you always find problems in the solution, you're not going to get, we're just going to be stuck with where we're at. And
you have to try, right?
Yeah, there are multiple problems with the solution and the implementation of it and the acceptance of it. And I think if anybody knows, Dana probably knows the most about these things. And he shared that as well. I think this standard is almost 10 years old, and like nobody knows about it. Like nobody knows about it at all. And I just think that, we have to at least try. If there's a better way of doing things, we owe it to ourselves to try to do better. Otherwise, what are we really doing? Every single day, it's part of the human condition is to grow, to learn, to challenge ourselves, go past the, go frontiering, find new ways to do things. And it's part of the game. And I think we need to try. Now, is this challenge large? Yes, it is a large challenge. But I think, with education, I think we can at least try to get there. And at the end of the day, if we try and it happens, great. If we try and it doesn't happen, great. At least we did something.
Well, we're getting up here on time, but I think I have one last question here on this point with IPC 2581. I think I agree with you to an extent that if customers, every customer showed up saying, why won't you accept my IPC 2581 file, that, fab houses would eventually acquiesce, right? So if we accept that that is the case, we have to then get more designers to start demanding that this be used and have to use it themselves. So what does it take to get more designers to be aware of this format, or even ODB++, and start using it? Like, does Altium need to go on a, massive marketing campaign and, tell people, hey, this is an export option that you have available for free and you can start using it immediately, and here's why it's so great? or does something else need to happen?
I think it takes a village. There's this thing that's already in the software that we just export, and it will save you a week or two in sending the data over to your things. And once they develop that goodwill with the customer, then they've built more trust with the designers, right? That is a way of doing it. The second way of doing it is, a lot of the CAM companies that we use should say, hey, use IPC 2581 because these are the advantages of it. And ask your customers because the ECAD companies already have it. It's like, great, we'll start using it. And then the board houses should say, hey, whenever we quote anything, ask for IPC 2581, maybe along with the Gerber data, because board house companies, and the board house CAM companies should say, hey, this will save you a lot of time and a lot of headache and a quality issue. So I think everybody needs to start understanding what it is, and everybody needs to start playing the role of just asking for it and educating it. If ECAD companies do that, and the first one that does it screams at the loudest, they may get even more market share because, the standard right now, they're not talking about it. But if the next guy who's hungrier starts talking about it and says, you can use this, people may pivot to that. So I think, and same thing with the EMS companies. Same thing with the board house, fabric. It could be a competitive advantage, and I think if you look at it that way, if everybody looks at it as a competitive advantage and starts pushing it and starts highlighting it, it could be adopted a lot faster.
We'll see if any of this comes to pass, because I feel like every few years we have this conversation again. But I hope the folks out there listening will take some time to look into IPC 2581 and, of course, look into Amtech and see how you guys can help them.
Yep.
Absolutely. Jay, thank you so much for being here today.
I appreciate it. It was a great conversation.
To everyone that's out there watching and listening, we've been talking with Jay Patel, CEO of Amtech. If you're watching on YouTube, make sure to hit the like button, hit the subscribe button, and you'll be able to keep up with all of our podcast episodes and tutorials as they come out. And last but not least, don't stop learning, stay on track, and we'll see you next time. Thanks, everybody.